Hello guys, today I'm gonna explain about the R-star tree, an efficient, robust access method for points and rectangles. The R-star tree have slightly higher construction cost than the R trees, as the data may have to be reinserted, but the resulting tree will usually have a better query experience. I'm going to explain about the following topics, which includes basic concepts, problem, significance, complexity, limitations and assumptions, extension, methodology, conclusion, and references. Concepts. These include four kinds of concepts, which are enhanced split algorithm, which is the R-star tree, which incorporates an enhanced split algorithm for nodes during insertion, and also it contributes to the maintenance of highly efficient index, leading to reduced query response times. The second one is quadratic split hierarchy. To determine the optimal split among the set of the candidate split, the paper introduces a quadratic split heuristic. The heuristic takes into account the distribution of rectangles, aiming to enhance the overall quality of tree structure. R-tree architecture. This is similar to an R-star tree architecture, which is a spatial indexing tree data structure. It also represents the bounding rectangles that can enclose set of spatial objects such as points or rectangles. The last one is minimizing or overlapping rectangles. In this, the R-star tree design addresses the challenge of overlapping between the rectangles. Also, by minimizing overlap, the algorithm reduces ambiguity in range queries, and therefore by improving the accuracy and efficiency of search operations. The first problem is addressing inefficiencies in R-tree structures. The research endeavors to tackle the limitations of conventional R-tree data structure, which is efficiently indexing spatial data. The hierarchical R-tree data structure is employed to recursively partition in the data space into rectangles, aiming into enhanced resilience. The second one is hierarchical organization. The rectangles within the R-tree represents within a set of group of data elements, and the organization which facilitates and also represents the spatial relationships within the indexed data. Next is clear problem statement. This problem statement is an introduction to paper succinctly, which articulates the challenges faced by our regular R-tree in indexing spatial data, and also it is a solution designed to surpass the efficiency and robustness of the traditional R-tree. The next is focus on improvements. This also implements such as the split method and resultant tree structure, which is inherent in the original tree. To overcome these shortcomings, the author introduced innovative concepts like overlap minimization, quadratic split hierarchy, and improved split method. The last and the final problem is solution proposal. In an effort to address the identified issues to elevate the overall efficiency of the spatial indexing, the authors advocate for the adoption of R-star tree. This is therefore the proposed solution, which incorporates the novel techniques to enhance the performance and resilience of spatial data indexing compared to the conventional tree. The significance also tackles the fundamental problem, since spatial indexing is essential for database and GIS applications. The R-star tree is also more efficient and adaptable to data changes for a range of query types. And since they know how much better the R tree is than the traditional tree, the results of papers are very important. Although improving SAM, which is SAM efficiency and robustness, is not a new problem, the paper might take a fresh and original method to it. And also, the R-star is expected to be widely adopted in the field of geometric and geographic data management, as it is significant improvement over existing SAMs. And the geographic information systems, which is GIS, for example, spatial database and computer graphics. Complexity. For finding the complexity of the R-star tree for a given set of data is complicated and very challenging. The problem is actually known to be NP-hard, which means there isn't a known efficient way to solve it and to solve the solution for it. The efficiency of geographic access methods is highly dependent on the size and dimensions of the geographical data. The problems with a computational efficiency could arise in the broad search space. Also, the most recent improvements for R trees likely aim to improve the efficiency of spatial requests and solve the problems with the search space concerns. It's challenging to determine the best R tree for a given selection of data because it's important to find a balance between efficiency and reliance. Coming to limitations and assumptions, exploring spatial access methods, which is SAMs, has been long-standing challenge in the quest for efficient and robust solutions. Also, it represents a significant innovative departure in addressing the intricate task of establishing a dependable and efficient SAM. Also, for acknowledgement of prior research, the author has been demonstrated various awareness on early research endeavors by citing relevant papers both in introduction throughout the paper. A critical examination of the strengths and weaknesses of previous SAMs is undertaken, with the focus of explaining why R star tree stands for a superior SAM. Challenges for assumptions in previous SAMs, which has only been about the data, potentially limiting the effectiveness, which the assumptions are not met or the level. The R star in the tree is contrast, avoids imposing the same context as its predators, enhancing its robustness in handling dynamic and diverse datasets. Coming to the last limitation, enhanced robustness through novel concepts. The paper addresses the challenge of finding a reliable and efficient SAM that does not rely on the assumptions inherent in the earlier models. The R-star tree achieves this by introducing novel concepts absent in the previous spatial access methods by elevating its adaptability that changes its data. Extension. By addressing flaws in the original art tree structure, this implies that the study that it's the topic which is not merely an extension but also an improvement to certain problems. The certain improvements such as improved split method and quadratic split method indicates the potential to new approach for the circumvent of art tree itself. The research also suggests that a novel and inventive approach all through improving SAM, the spatial access method efficiency and robustness is not a new problem, as it's because the R-star tree provides a significant improvement over existing SAMs, which is also anticipated to be widely used in the field of geographic data management. This is likely that the study offers several state-of-art methods and algorithms to improve spatial indexing. A few instances of particular are the overlap minimization techniques. The enhanced split method and the quadratic split heuristic is one of the overlap minimization techniques. Moving on to the methodology, thorough investigation of R-star tree data structure indicates that they underwent comprehensive examination, prompting that the author of the paper to strategically choose their methods. This study encompassed a variety of test, theoretical analysis, and illustrative examples, which are allowing for a comprehensive assessments for the R-star tree for multiple perspectives. And moving on to the next methodology, which is sound and well executed methodology. This employs a robust and a well executed methodology as the author skillfully present a compelling argument by a combination of empirical tests, theoretical insights, and illustrative demonstrations. And finally, anticipated widespread adoption, which is demonstrated advancements. It is expected that the R star tree will find extensive application across various domains. The paper positions the R-star tree as the noteworthy evolution in the field of geographic data management, suggesting its utility and relevance for numerous and various applications. And finally, the conclusion of the paper, the R-star tree, an efficient and robust access methods of the points and rectangles, which is given by the Norbert Beckmann, Hans-Peter Kriegel, Ralph Schnitzler, and Bernhard Seeger. The R-star tree stands out to be a substantial improvement over the original R-star tree, demonstrating superior reliability and efficiency across the diverse range of queries. Um, its exceptional performance persists when handling heavily skewed and clustered data, making it a valuable addition to the field of spatial data management with the anticipated widespread applications. And also, the data may need to be reinserted, but the resulting tree will usually have the better query experience for the R star tree rather than the R trees. The strengths of the R star tree is enhanced efficiency of various query types and increased robustness to changes in data. Whereas the weakness of R-tree is insertion and deletion operations will be more integrated compared to the standard of R-tree. In summary, the R-star tree proves to be highly effective and adaptable spatial access method suitable for multitude of applications, which is despite that increased complexity in certain operations, it is also improved the efficiency and resilience to make it notable advancement in the realm of spatial data management. These are some of the references that will help you in letting know about this R star tree, which will improve in the efficiency and management so that you can know and learn more about the data and information related to it. Thank you.